In this video I'm going to look at multiplying integers using models, and I'm going to use the same models that the MathLinks grade 8 textbook is showing. Okay, so in that textbook what they do is they have these little red integer chips and these little blue integer chips, and just for our notation today, red is +1 and a blue represents -1. So if I wanted to show +2, I would simply draw two red chips that are positive. Okay, and I put the positive and negative sign in them in my own drawings just because it makes it a little bit clearer, especially if you're going to draw at home just using pencil. So put the plus or negative sign in there for me, positive or negative sign in there for me. Okay, and so in grade 7 you would have talked about this concept of a zero pair. And so a zero pair really is just, in our model, represented by one red chip and one blue chip. So these guys together create a zero pair because I have a positive as well as a -1. And +1 plus -1 is 0, right? So you could think of like finding a loonie on the ground, and then you later lose that loonie out of your pocket, and all together you have $0, right? If you pick up $1 but then you lose $1 or spend $1, you're back to 0. So this would create what we would call a zero pair. Okay, and we do work with zero pairs. We kind of keep them in mind as we keep going through integers, but really it's more of a model thing that we use, but I will refer to it from time to time. So if I look at this one here, this is still also a zero pair. It's just 3 zero pairs all put together, right? Because I've got one zero pair there, a second zero pair here, and a third zero pair there. Really, the whole thing is still a zero pair, and it's kind of like having +3 and -3. I have one integer and its opposite, and so when I add them together, I would get 0, so they form a zero pair. Okay. Alright, so what I'm going to do is I'm going to model this multiplication of my integers using those chips. So remember, red is positive, blue would be negative. Okay, and so when I'm looking at this here, +4 times +2, this is actually what we've been doing since you started multiplying way long ago in elementary school. So if I look at this, +4, the +4, what I'm going to do with that is that one is telling me to add 4 groups. Okay, so I'm going to add 4 groups into what I'm doing. So I want to think of this rectangle, or I guess rounded rectangle. So think of this as like your desk. And what I'm going to do is, right now my desk starts with nothing on it. I have a nice clean desk where right now everything here just equals 0. Okay, I'm starting off with nothing. And what I'm going to do is I'm going to add to that nothing. I'm going to add onto my desktop, I'm going to add 4 groups of something. Okay, the 4 groups that I'm going to add, each group has +2 inside of it. So I'm going to add in 4 groups, and each group is going to contain 2 positive integers. So here's my first group, where I've got 2 positive integer chips, and there's my first group that I added onto the table. And then I'm going to do the same thing again. Oops, I'm going to add the same thing in again. Okay, I'll add in 2 more positive integers. And then again, 2 more positive integers, and again. So that in total, I've now added onto my desktop 4 groups, so those are the yellow things, and inside each group I've put 2 positive integers. And what that gives me now, in total, my table or desktop has now gone from equaling 0, because it had nothing on it, and now it has 8 positive integers on it, so it becomes +8, and that would be my answer here. Okay, so +4 times +2 is +8. Okay, let's do another one. So same idea. I'm starting with a blank desktop, so right now this equals 0, right? It is blank. I've got nothing on there. Okay, first thing I'm going to do is I'm going to add in 3 groups. So I'm going to be putting 3 groups of things onto my blank desktop. Okay, inside of each group I'm going to have 2 negatives. So I'm going to add 3 groups, 1, 2, 3 groups, and I want inside of each of those groups for there to be 2 negative integer chips. So I'm going to put in 2 negatives into each group. And I've added those groups onto what was my blank desktop. My desktop equaled 0. And so now my answer, when I remove all of the outlines of the groups, I've taken what was 0 and I've added onto it these 6 blue integer chips, and those 6 blue integer chips represent -6. And so my answer to the multiplication is -6. Okay? So when we're adding groups onto the desktop, that's pretty easy. That kind of makes sense. What do I do here? This is where it gets confusing. It says -2 times -5. And so that -2 means I'm going to take away 2 groups. Well, right now, I have nothing on my desktop, right? I have nothing on this rectangle right here. I have 0. How can I take something away if I have nothing there? Well, this is where that idea of the 0 pair comes back into play. I've always said that the desktop is blank, but that it has to equal 0. So what I'm going to do is I'm going to add in a positive chip, and I'm also going to add in a negative chip. And every time I add one positive and one negative together, this creates a 0 pair. So right now, my desktop is still 0. So I'm going to keep on adding in 0 pairs, because I can add as many 0 pairs as I like, so long as I make sure that I have an equal number of positives and negatives, so that my desktop still stays at a value of 0, I'm okay. So remember, I've always got to start with my first desktop being 0. And I'm either going to add things onto the desktop or take things away from it. All right, so I've got 10 positives and 10 negatives. Because I have equal number of both, it is still 0. Now, I wanted to take away 2 groups. And inside of each of those groups, each group should have 5 negatives in it. Okay? So I'm going to take away 2 groups where each group has to have 5 negatives in it. So if I look, here's my first group of 5 negatives, and I'm going to take it away. So I'm going to draw my arrow saying I'm going to remove this from my desktop. Here's my second group of -5. And I draw my arrow pointing away saying I'm going to take this off of my desktop. Okay? When I remove those blue integer chips, the only thing I would have left would be my red integer chips. So when I take away my negatives, I'm going to be left with my positives. And so when I look at my answer, there are 10 positive red chips, so the answer is positive 10. Okay, when I take away those, that did not look like a 1. When I take away those 10 negatives, I'm left with 10 positives. Okay, now again, because I started with 10 of each, I still started at 0. And what I'm doing is I'm taking this group of 5 blues and taking it away. And I'm looking at this group of 5 blues and I'm taking it away. And this here is what is left over. Okay? Now, I was very particular there. I made sure that I had the right amount. What if I don't know the right amount I'm going to need? So again, here we look. I'm going to be taking away 3 groups. I have nothing to take away right now. Okay? It's 0. I've got nothing to take away. So I know I need to be able to take away 3 groups of something. Okay, so I'm just going to write in a bunch of integer chips here. How many do I have? 2, 4, 6, 8. Let's put in, we'll say 12. Okay, so there's 12 positives. So if I'm going to add in 12 positives, I need to make sure that I add in 12 negatives. So there's 6, 7, 8, 9, 10, 11, and 12. Okay, So I'm going to take away 3 groups, and inside each group I need there to be 3 positives that are getting removed. Okay, so I'm going to circle 3 positives. So 1, 2, 3 positives right there, and I'm going to draw an arrow saying I'm taking them off of the table. And then I've got 1, 2, 3 positives right there, and I draw an arrow saying I'm taking it off of the table. And I still need to do one more group of 3, so I'll do this group of 3 down here, and I'm going to draw my arrow to say I'm taking them off of the table. Okay? When I take away those red chips, here's what I'm left with. I still have 3 red ones, because I guess maybe I drew too many if I've got extras. And then I still have my 12 blue ones, and I'm just going to write it a little bit differently, and you'll see why in a second. Okay, so I still have my 12 blue ones, and I still had 3 red ones. Now this answer looks a little bit different than what we had before, and that's because I drew too many integer chips. I didn't need to do 12 red and 12 blue. I did too many by accident. But you know what? It ends up being okay, because look, this positive and this negative group together to make a 0 pair. And this positive and this negative group together make a 0 pair, and so does this one. And actually this looks like what we had on our first slide, right? These 3 positives and 3 negatives, they make a 0 pair. So actually really, I don't need to have them there at all. I could erase them and I wouldn't change my value because their value was 0. Okay, so I added too many. I didn't need to have 12 red chips. I could have started with 9 red chips and 9 blue chips. Alright, and you can see now that we've got those 9 blue chips left over, and we get -9. So that is using models to show integer multiplication. I won't have you do too much with them, but I wanted you to have an understanding of where it came from.